Moore's did with TSMC, his insight, was instead of being a product company, TSMC would be a platform company. It would build no products. It would enable other companies to build products. That insight, although so clear now, potentially one of the most sustainable semiconductor manufacturing business models going forward, the foundry business model, was absolutely unclear then. Was absolutely unclear. Instead of manufacturing one or a few products very, very well, they manufacture umpteen thousand products at a time. This is a company that manufactures, that makes something that I have utmost confidence right now as I speak that every single person in this audience has in his possession. This is the only company that I know that at this moment there's something in your possession right now that is manufactured by them. I believe that to be a test that will pass. Whether you have an iPhone or a Samsung Galaxy or an iPad or whatever it is, of all of the companies you know in the world, this is the only company that currently has something they make in our possession right now.
What does TSMC do? Let's begin by understanding how semiconductor devices relate with the end products that we are all familiar with. We are all familiar with smartphones, right? This is the end product that consists of many semiconductor devices. Let's take Apple iPhone 13 as an example. In order for this phone to operate, it requires many different semiconductor devices to function. If we tear down the iPhone 13, we will see that it comprises of three main PCB segments. In the first segment, you would observe a total of 14 different semiconductor devices assembled together. These are supplied by many different companies, including Apple themselves, Texas Instruments, ST Microelectronics, Skyworks, Avago, NXP, and Qorvo. In the second segment, you would observe a total of 6 different semiconductor devices assembled together. These are supplied by mainly Apple themselves, NXP, and Kioxia. In the third and last segment, you would observe a total of 16 different semiconductor devices assembled together. These are supplied by Skyworks, Qualcomm, USI, Murata, Qorvo, Avago, and Broadcom. Therefore, all in all, we would require a total of 36 different semiconductor devices from 13 different companies in order to ensure the iPhone is operational. Now that we understand the concept of semiconductor, let's move to understanding semiconductor is made and what is Foundry's involvement in this.
This is iPhone 13.
Before each company can ship their semiconductor devices to Apple for the final product assembly, these devices will go through 4 main steps that are wafer fabrication, package assembly, testing, and packing. Let's look at each of these steps deeper. First step, wafer fabrication. Think of this step like creating the brain of the device. This is a process of making thin, flat semiconductor wafers. One wafer consists of numerous chips or dies. Next step, package assembly. This step is like connecting the brain of the device with its body so that this device can interact with the final customer's end product like the Apple iPhone. Package assembly starts from wafer sawing, where the individual chips are singulated within the wafer. Then, the singulated chip will be bonded with gold or copper wires, which are used to connect the chip to the body of the package. Next is the encapsulation process to protect the silicon chip. Finally, laser marking to identify the device type. The third step is testing. The objective of this step is simple, to ensure devices can function. Once devices are confirmed good and functional, they will then be packaged to be shipped to the customer. Coming back to the main steps in semiconductor, TSMC is a company that creates a platform to fabricate the wafers based on the chip design that companies provide to them. Such company provides this platform service is called a foundry. Today, TSMC is at its monopoly on the foundry business, owning approximately 60% of the global revenue. Let's look at TSMC's top 5 customers that contributes to its revenue. First, Apple at 25% of TSMC revenue. Second, NVIDIA at 10% of TSMC revenue. Third and fourth, Avago and Qualcomm at 6.5% of TSMC revenue. Then AMD at 5th with 5.5% contribution to TSMC's revenue. In 2024, TSMC served 522 customers and manufactured 11,878 products for various applications covering a variety of end markets, including high-performance computing, smartphones, the Internet of Things, IoT, automotive, and digital consumer electronics.
On 1,100 acres in the middle of the Arizona desert, only one set of buildings rises above the horizon as far as the eye can see.
We started construction well before the CHIPS Act came along, and that's in April of 21.
This recently completed 3.5 million square foot building is Taiwan Semiconductor Manufacturing Company's first Arizona chip fabrication plant, or fab, making history not only for its enormous size, but because it's by far the most advanced chip fab on U.S. soil. So pilot production has started in this building. When we were here 3 years ago, it was steel beams and dirt. What kind of investment has it taken to get to this point?
About $20 billion.
When we first visited, TSMC was far from a household name, but the chip shortage and AI boom has thrust it into the spotlight. TSMC manufactures some 92% of the world's most advanced chips, in everything from NVIDIA GPUs to Apple iPhones. And now, for the first time in history, TSMC is starting to make those advanced chips here in the US. Customers like Apple are starting to make their chips here, with 2 more fabs planned by the end of the decade.
The facility over here is our Fab 2. You can see the steel has been completed.
But bringing advanced chip manufacturing to the US has proven difficult. Volume production, supposed to begin this year, is delayed until 2025. The Commerce Department recently hit TSMC with new shipping bans after its chips ended up in Huawei devices despite export controls. And incoming President Donald Trump stirred up fears when he expressed opposition to the CHIPS Act during his campaign. TSMC is getting $6.6 billion from the bill.
Those who follow the crowd never see beyond the crowd. It's the trailblazers who dare to innovate that rewrite the rules and define the future. In 1987, Dr. Morris Chang pioneered the dedicated semiconductor foundry business model. By redefining roles, this business model reshaped the semiconductor industry landscape, unleashing the power of innovation and giving rise to new exciting advances over the past 30 years. The world has never been the same. For those who yearn for innovation, TSMC ignites the spark that propels them forward. Constantly expanding the frontiers of semiconductor technology, we are there to support our customers wherever they are. Empowered by the leading portfolio of silicon IP and libraries, we've built the industry's most advanced design ecosystem to deliver a comprehensive range of technology services to customers.
TSMC's business model is simple, yet incredibly powerful. Focus on manufacturing, perfect the technology, and serve the biggest names in tech. From a bold experiment in 1987 to a global tech powerhouse, TSMC has changed the world in ways few companies ever have. As the semiconductor industry evolves, one thing is clear: TSMC's impact is far from over. If you enjoyed this breakdown or have more questions about TSMC or other companies, leave a comment below. Don't forget to like, subscribe, and hit the bell icon for more simple explanations of complex topics. Thanks for watching, and I'll see you next time.